Fish drained of blood. Strange circular bite marks. Long, sinuous, and bloodthirsty. Most people know lampreys as the vampires of the sea. Despite their many rows of sharp, pointy teeth, only 18 of the 39 known species of lamprey can really be called vampires. In fact, the majority of lampreys are non-parasitic. All non-parasitic lampreys descend from a parasitic ancestor. Non-parasitic lampreys and the parasitic lamprey they descended from are known as paired, or satellite species if there is more than one descendant. Paired species have few differences genetically, which allows for crossbreeding, and there are even a few cases where individual non-parasitic lampreys have given birth to parasitic forms. Despite this, there are consistent differences between parasitic and non-parasitic lampreys. One major difference between parasitic and non-parasitic species is that non-parasitic species do not feed as adults. Both parasitic and non-parasitic juvenile lampreys filter feed, but parasitic species feed on fish after maturity. Non-parasitic species spend longer as amocoids, which are juvenile lampreys, than parasitic species, although how much this differs is complicated by the fact that time spent as an amocoid can vary even within a species, which may be due to the amount of food available to a specific juvenile. One consequence of this is that non-parasitic species are usually larger at maturity than parasitic species, but by the time they spawn, parasitic species have experienced a period of rapid growth and are usually bigger. Perhaps unsurprisingly, non-parasitic species tend to have smaller, duller teeth than parasitic species because they do not use them to feed. However, another consequence of not feeding as an adult is that the gut of non-parasitic species quickly atrophies, which can affect osmoregulation and their ability to live in saltwater. Therefore, all non-parasitic lampreys are freshwater fish, while some parasitic forms are anadromous, which means they can live in both salt and freshwater. Despite half of modern lampreys being non-parasitic, the reason why so many species have lost their parasitism remains a mystery. My theory is that some lampreys, somehow prevented from migrating to the ocean, may have remained in the filter-feeding amocoid stage longer as an adaptation to survive, the lower numbers of fish that they could feed on, and eventually lost their ability to feed as an adult at all. This is supported by the existence of pricock species, which are intermediaries between parasites and non-parasites, which spend less time at sea. However, recently landlocked species of lamprey, Lampetra tridentata, have still tried to migrate and show no signs of losing their parasitism. Although lampreys may not be keystone species in their ecosystem, they still deserve to be understood and protected. Understanding how they work is half the battle. Non-parasitism in lampreys is a fantastic example of how much lurks below the surface of even the most simple-seeming species.